Hello everyone, welcome. It's my first time here in Poland, so I'm really happy to be here. So, as Martin said, we will talk how serverless can complement microservices. So it's all about services, in fact. My name is Rafael. I work at Red Hat for almost 9 years as a director of developer experience, which is basically going worldwide, meet with customers, meet with people like you here, and understand their needs of technology so I can return to Red Hat and say, that's what developers want. And then get those things that Red Hat are producing and present to you. So that's why I'm here. But essentially, I'm a Java developer, okay? My background, I started as a Java developer. I still produce a lot of Java code. So that's it. I don't know how many of you noticed, but I took a picture of you, just like a selfie, and I will publish that in my Twitter. My Twitter handle is @Rafa Bene, and I will also post the slides. By the way, I have several links in these slides. I have links for ebooks, I have links for articles, links for the demo. And you can you can access the slides at this moment going to this web link here, bit.ly/serverlessfull. Okay, you can access the slides at this moment. And before starting our talk, this talk specifically, I'd like to invite you to join the Red Hat Developers Program. You just go to the developers.redhat.com, and there you can find useful resources for us, for developers. There you can find free ebooks, like microservices for Java developers, building reactive microservices in Java. You can just download it free. You just need to register, and I promise you, we will not spam you. We'll send an email once a month with the list of the most popular things, like articles and blog posts, webinars. There's also this book from Edson Yanaga. Edson Yanaga will be here presenting a session about ISTO. We'll also do a workshop about ISTO on Friday, migrating to microservice database. And there is also this book introducing ISTO Service Mesh for microservices. Well, this talk that I'm presenting here today is based on the Red Hat keynote that happened on Red Hat Summit last month. So we took the last technology trends like microservices, service mesh, functions, and we did a presentation using an interactive game so people could use the application and see how it behaves at real time. So this talk is based on this demo. It was really nice, and I bet that it will be really nice for all of you to see it as well. So let's start with a phrase from this guy here. I don't know how many of you know Thor, but he said, our ancestors call it magic, but you call it science, computer science. I came from a land where they are one and the same. So if you think about all of the years of evolution, we can, if we were like 10 years ago, and we take a look on the things that are happening at this moment, we can somehow think that's a kind of magic with all the automation and all the things that are provided and tools that are provided in our hands as developer or as even sysadmins. For many, many years, we had a monolith application, right? It was easy to develop. It was easy to deploy because you deployed just one single piece of code, or your code was packaged together. You just deployed. But then you started to realize that you were producing spaghetti code, so you decided to break it down in modules. But modules was not good enough because everything was still tied together. So there came microservices. With microservices, things start to get interesting because now every part can be developed using different technologies. They can even be deployed on different moments. I can deploy one piece today, another microservice tomorrow, and that's the beauty of microservices being independently deployable. Because they are independently deployable, you can spread them on a network and create a network of services, a service mesh, with microservices communicating with each other. Of course, every microservice has its own database. Some of them have multiple points of entry, and we forgot about the fallacies of distributed computing. Somehow we tend to forget, and we tend to think that the network is always reliable, and that's not true. It will fail. It's not that it can fail or it might fail. It will fail at some moment, at any moment, and we need to be prepared for that. We forget that we tend to think that latency is zero. We tend to think that the bandwidth is infinite, that the topology doesn't change, that there is one administrator. Also, it's for us developers, it's easy to forget about the costs, and we tend to think that the network is homogeneous. But since all of these things that I mentioned are fallacies, we need to be prepared for a failure. Because if a failure happens on a service, we don't want that failure to be cascaded to all the other services. We need to be prepared. And to be prepared, every microservice in this network mesh needs to implement certain features, certain capabilities. Like, for example, let's talk about Java microservice. A service A needs to communicate with a service B and service C. But that service A needs to implement the service discovery, it needs to implement a load balancer, but it also needs to implement resilience, be tolerant fault with circuit breakers, retries, and things like that. And of course, in a distributed scenario, it's good to have metrics and tracing. So every microservice, like microservice B, it also needs to have discovery, load balancer, resilience, metrics, tracing, and so on. The same thing for C. And if we look at this slide here, we can see that microservice is somehow new. But in fact, it started in 2012, so like 8 years ago with Netflix, and then it came Ribbon, then it released Hystrix, Eureka for service discovery, Microservices, the ThoughtWorks Radar in 2012, so we are talking about 6 years ago. And let's be honest, 6 years in the IT industry, it's a lot of time. Then we came Docker on March, Spring Boot on September of 2013. Microservice was defined. But everything was based in the Java ecosystem, was based on Netflix OSS. But what's wrong with Netflix OSS? It's only for Java. It's a Java library. It's Java only. So it adds a lot of libraries in your code. So if you need to perform service discovery, you need a Netflix OSS library for that. If you need to perform metrics or tracing, again, you need to add libraries to your code. So if you think about a microservice, no matter if you are using Vertex, Spring Boot, MicroProfile, or Node.js, Python, for every microservice, you will need the same capabilities. You need a well-defined API, right? You need to have a way to that service to be discovered. You need to define a way to invoke that microservice. You will use REST, a messaging system. How will have elasticity, resilience? How is the pipeline to get that service, to place that service on production? How will you perform authentication, logging, monitoring, tracing? So these are the microservices, the microservice needs for each microservice. Fortunately, with Kubernetes and OpenShift, some things that you don't need to have a Java library or a library anymore on your code. Because with Kubernetes, for example, you can have a built-in discovery. You can have a built-in invocation. You have a built-in elasticity. With you can scale easy. It has also automatic horizontal auto-scale. With OpenShift, on the other hand, we can also have monitoring, logging. OpenShift also provides a pipeline. And the rest of things can be provided by ISTO. ISTO is an implementation of Service Mesh. Service Mesh is when you have a collection, an infrastructure that will intercept the traffic from an inbound traffic and an outbound traffic to and from a microservice, and you can manage the traffic centrally. So I will show to you an example of Service Mesh using a website here, learn.openshift.com. There is a Service Mesh training here where you can see, you can try that later in your home. There is advanced route rules. And you don't need to install anything on your machine. You just hit the start scenario, and then you can run a script that will install all the microservice locally. And I will show one or two examples of Service Mesh. But let me explain to you, while these microservices are being installed, what ISTO can provide. So ISTO can provide to you a built-in mechanism for tracing, for monitoring, for authentication, which is good because you can have a mutual TLS based on certificates authentication. It can also provide resilience because everything that you needed to code related to retries, circuit breakers, that can be implemented with ISTO. So, for example, before ISTO, you have those things that I said implemented inside your application. But after ISTO, you will have a sidecar container deployed together with your application. And then this sidecar container will intercept all network traffic, and then you can have those things that I said, like retries, circuit breakers, everything. This sidecar container uses a proxy called Envoy. Envoy is very performatic. It's written in C. You can see, you can take a look here at their website. It's called envoyproxy.io. So Envoy is an open source edge and service proxy designed for cloud native application. Okay, so with Envoy, it provides to you as a proxy intelligent routing and load balancing. So you can have A/B testing tests, for example. You can have smart canary releases. In fact, I will demo a smart canary. You can also perform testing like chaos testing, injecting faults on your application. You can have resilience, as I said, with circuit breakers. You can have observability with metrics and tracing. And, of course, you can have a fleet-wide policy enforcement. Like, I want to define a blacklist of services. I can define the opposite. I can block everything and just define a whitelist of services. So, since every part of your application will have an Envoy sidecar proxy deployed, it needs to be managed by what they call a control plane. So a control plane, it's a collection of the ISTO pilot, the mixer, and of course the ISTO CA that will provide the certificate authority. So let's take a look here on a demo of ISTO. So my microservices have been deployed. I can see a list of existing microservices. So I have a customer microservice that will call preference microservice that will call recommendation, and I have two versions of recommendation. I have recommendation V1 and V2. Let me just increase the font size here so you can have a look on the existing pods that I have deployed. Let's invoke the microservice here. So you can see this is the result that I have. Since I have the version 1 and the version 2, they are both being replied at the same time. So I guess that many of you are familiar to Kubernetes, right? So please raise your hand who is familiar with Kubernetes. Cool, a lot of people, that's great. Because ISTO uses the same concept of YAML files. So instead of defining a service or a deployment, you can define, for example, a route rule. In this case, I will perform a smart canary. So I have a route rule here that says that I want that every time that the destination is recommendation, I want to route 100% of my traffic to the version 1. So it's easy. I just need to apply that to my ISTO environment. And look here, when I try my microservice again, I just have V1 replying. So this is really nice for managing your microservice. But now I want to do something more advanced. I want that every time that my browser has a header on the request that contains Safari, I want to route to version 2. So let me apply that route rule here. Okay, and let's keep trying our microservice. So you can see that V1 is still replying, but since my web browser contains the agent header Safari, I can open it on my browser and I will see V2. If I use the same URL with Firefox, for example, Firefox will show me V1 because I don't have the Safari user agent on Firefox. So that's one of the powers of ISTO to manage your microservices. Of course, I can try that with curl. If I send a curl with the agent Safari, I will use agent Safari here. I will see V2. If I send the agent Firefox, I will see V1. So that's really nice. Let me delete the route rule here and show another example that you can do with ISTO. Just as a reminder, there will be an ISTO workshop on Friday. Just take a look. Keep an eye on it, and you can join. Another example that I will do here with ISTO is a dark launch. One of the greatest examples of dark launch was Facebook Messenger. Facebook Messenger was released 1 year ago before you've seen it live. What they did, they placed the Facebook Messenger mechanism, the Facebook Messenger servers behind, and you didn't see it on the front end. And every time that you send a post on Facebook, they redirected the post to to the Facebook Messenger. That way they could test how performatic, what are the potential bugs, and when they release, it was like a success because it was tried a year before you ever seen it. And you can do that the same way with ISTO. So for example, we have here recommendation V1 and V2. I can apply a rule that will say, send every request to V1, and I don't want to send any request to V2. I don't want to, but mirror the request to V2, which means that V1 will reply, V2 will receive the request also, but it will not reply to the user. So let's apply that route rule so we can see how it behaves. Okay, so I applied the route rule. Now I can try the microservice. Here I can see only V1, because that's what I asked. I want 100% of the weight to arrive to V1. But if I take a look at the logs of V2, I will see here that V2 is also receiving the request. It never replies. You can see here the counter, that it's 600. And V2 is still receiving requests, but you've never seen it. It's an example of dark launch. So that's another example of things that you can do with ISTO. It's very powerful, and it really helps for those who are playing with microservices. Of course, another phrase here that's from Spock, change is essential process of all existence. So let there be functions. So between functions and microservices, there's a sort of different paradigm. Because with microservices, you still have control. You control the language that you will implement. You control how you will deploy. You control the architecture, of course. They are not only for a long-lived process, but they can be used for a long-lived process. For example, if you open a WebSocket to that microservice, you will have a long-lived process. It's a known programming model. Of course, if you are using Java, you will program in an object-oriented way. Often it's sync request response, and it's very mature, right? There are several IDEs because it's still the same programming model that you used to have for many years. What you changed was the way to deploy the application. So you have debuggers, tracers, monitoring, CI/CD. It's very familiar, right? But with serverless, you don't have the control. The cloud has the control. Okay? Usually, it's meant to be used for a short-lived process. And of course, it's a new programming model because even if you decide to use Java, you still need to program Java in a functional way. And usually, it's more, instead of being a sync request response, it's more event-driven async. And we can think that's a little bit immature because we don't have many support from IDEs yet. We don't know how to perform debugging on functions, how to deploy. So those things still need to be, they're under discussion. The IT market is adopting some practice, but in fact is that we don't have a standard yet for IDE, for development, or even for an environment. So serverless defined. Well, serverless is when you have a backend as a service. It's called serverless because, in fact, you don't have a server always on. You perform a request to a function, the function executes, and it dies. That's why it's often, and it should be stateless. Okay, some people are talking about stateful functions, but we even had a joke that there will be a moment that there will be that we are returning to AGBs, where we have stateless and stateful functions. that could be passive, that could have a client interface, but that was, of course, a joke. So the purpose of serverless is also to reduce the cost, because you don't need to, since you don't need to have your servers always on, you can just call the function, it executes and dies, and you just pay from what you used. Some cloud providers charge you by queries, another one charges you by CPU cycles. But the fact is, there are servers involved on serverless. The fact is that you don't manage them, okay? But before going to functions or before going to microservices, you need to ask yourself, is there something that I can buy? Or is there something that I need to build? Because it's all about services. If you think about the cloud providers nowadays, you can buy HTTP input and output service, like an API gateway as a service. You can buy an authentication service, right? An SSO as a service. You can buy a file storage as a service. You can buy data services, like databases or cache implementations. You can buy connectivity services, like notification or messaging. And then you can place your microservices on this collection of things that you can buy. If they are not existent, if they don't exist to buy, then you create yourself that microservice. And functions can be used as an event-driven input that will connect the existing services to the service that you build, like the microservice that you build. Or you can use functions also like event-driven output. And that can and will create a synergy for your application, because you have things that you can build, functions, and of course things that you can buy. There are some implementations on the market about functions. There is Kubeless, there is FN, the project FN from Oracle. There is Fission, OpenFaaS, Riff from Pivotal, and Apache OpenWhisk, which I will demo in this presentation. This presentation is focused on Apache OpenWhisk, mostly because it integrates really well with Kubernetes. So you can notice that as more you go to the right-hand side, less you need to concern about the server management, the virtual machine management. You have more automation. So when you have finally function as a service, you just need to care about the business logic. Okay? Which is really good. You don't need to concern about your application, your data, how to manage the containers, the operational system. That's all provided to you. And something that I chose Apache OpenWhisk to show is because it's a platform that allows you to write functions using different languages. Some function engines just support Node.js, another one support Node.js and Python. And with OpenWhisk, you can see that it supports JavaScript, Swift, Java, Python, PHP, Docker, and Go. And as I said, it can run in any platform where Docker can be run, or even, in this case, Kubernetes and OpenShift. So let's take a look on OpenWhisk, for example. To manage OpenWhisk, you have a command called WSK. Let me increase the font size here. Let me make it a little bigger. Yeah, WSK. I can do, for example, WSK action list to get the list. Oops, let me get the list of existing functions. And I can see that some of them, most of them were implemented using Node.js. There is a sample here called samples greeting with this name. So to invoke a function, I can do WSK. To know a little bit more, before I invoke a function, I can get the function to see what this function is about. So WSK action get, I just give the name of the function, WSK action get, that will return to me the name, of course, the description. It says that it returns a friendly greeting. There's a sample output, so hello cat from Norrisburg. I can see that it uses an environment node, which is Node.js. I can use some parameters that are not required, like name and place. So let's invoke this function. So instead of action get, I will write action invoke, and let's use some parameters here. Param name, Rafael, place, Krakow, and I want to see the result immediately. Param place, yes. So I can see here the return payload. Hello, Rafael from Krakow. If I don't specify result, it means that it will create an activation. So I have here an ID for that activation, and then I can get this activation later with WSK activation get, and I can send the ID, and that will return all the details of that invocation. So the response was success, and the result is hello, Rafael from Krakow. That's an example of how you can use an existing function on OpenWhisk. But let me show you here how to create a new function. I have an implementation here that uses JavaScript. Okay, so you can see that's very straightforward. I receive parameters. I can look for inside the parameters for the body. That then I will print JavaScript on OpenWhisk on OpenShift. So to create a function, I will use WSK action create. I give it a name, message action. Then I use the name of the file, message action.js. Once that message is created, I can come here and invoke my message informing the parameter body, text, my stuff, and ask for the result. So I have here JavaScript on OpenWhisk on OpenShift. What about if I want to replace that to Python? So I have also here an implementation using Python. Same thing. I receive a lot of parameters, then I can get the body and print Python on OpenWhisk on OpenShift plus the parameter body text. So I use here action create. And this time I will do action update and replace the JavaScript file by the Python file. And I can perform the same invocation here that I did before. I invoke it, and I can see here Python on OpenWhisk on OpenShift. So you saw that I used the same invocation and replaced the language, and that was transparent to the user. Okay? Well, but what about Java? We did some examples here using JavaScript. We used Python. And what about Java? For Java, we can, the Apache OpenWhisk has a Maven archetype that I have previously cloned locally and installed it locally because it's still an incubator, so it's not deployed yet on Maven Central. And to generate a Java project, I just need to run this Maven archetype create. So let me remove the previous folder, run the Maven archetype generate. That will generate the Maven project that contains my Java function. You can see that's really, really simple. It's just a Java class inside a package called conExample function app. I have a main method that will return, hello, welcome to OpenWhisk. So let's use that Java function. So Maven clean package. Okay, we need to create a package first. Okay, but I need to be in the folder, in the right folder. And the difference here is that to create a function, what I use to inform just the file. In this case, for Java, I need to specify, of course, the jar file and the main class. The main class is conExample function app. Okay, now that I have the function defined, I can perform the same invocation. Since I didn't modify this to accept any parameter, I will just remove the parameter here and get the result. And it replied, hello, welcome to OpenWhisk. That's my Java function. And you can see that it's really fast. Given that it's Java, you don't need to wait the JVM to bootstrap. And how that's possible? Let's take a look here inside my Minishift console. I'm running everything here locally, okay, and in my OpenShift cluster. So let's take a look here on my pods. This is the list of pods, and I want to filter. Let me increase the font size a little bit to help you people. That's our so nice audience. I want to see every pod that's active. Note here that when I invoke my function, it was really fast. Status in active. Yes. It's not active. Status in more labels. Status in active. I want to show you that no, not inactive. Done. So now you can see it. It keeps a pod in a paused state. So every time that I invoke my function, or if I invoke it several times, you can see that it creates a pod, executes the code. So the code, the Java class is already running, and then it removes or it pauses the container. So it makes it really fast and simple and reduce the cost of having your code always running. So what about web actions? I can, for example, create the same action, but using the flag web equals true. What it does is to define a URL for that function. So now that that function, if I use --URL, it will return to me an URL that I can open. And if I ask here for the JSON file of this action, you see here the same return. So when you access that endpoint, of course, you can post parameters using the HTTP post, and those parameters that are sent through HTTP post will be placed on it will send to the function, and then you can get the result on this endpoint. So this is really, really nice. Okay. Well, let's play with things a little bit more complex here. I have defined a function called splitter. Splitter receives a string with comma-separated string, where I can send that string, and the function will split it. So, for example, let's place here some words, like, for example, Rafael Benevides, Krakow, Poland, what else? Java, Devoxx, PL. The result I will write to this file here, split.json. So I invoke it, and now I have here the string splitted in an array of strings. So Rafael Benevides, Krakow, Poland, Java, Devoxx, Poland. Now I will use another function called sorter, but this time I can use the previous file as a parameter. So I use the split.json as a file and get the result. And now the result sorted, alphabetically sorted. Benevides, Devoxx, Java, Krakow, Poland, and Rafael. And finally, I have also a function that will get the sorted JSON output and make everything uppercase. Okay, let's wait. Now we have everything in uppercase. But that seems to be a little bit hard, right? I have to invoke 3 different functions and getting the result and pass to the next one. So what I can do is write a sequence, a function that will invoke the existing functions as a sequence. So the sequence will be first split, then uppercase, then sort. I have that function already defined. In that case, I can use, instead of create, I can use update. And finally, I can invoke that function using the parameters that I said. They invoke the function that I defined, the sequence function, split, upper, and sort. So my text was Rafael, Benevides, Java, Devoxx, PL, Krakow, Poland. So let's invoke. Now we have only one single invocation, and you can see that all the functions was invoked once. And you can see here that it created the 3 pods, one for each function, and now I have the result. So that makes things really, really easy. In a function world, we have some terms. We saw actions. We saw a lot of actions now. There's also a package. A package is when you can group, like a Java package, you can group existing functions that are similar inside a package. You have feed, just like the name says, it will feed your function engine. You have trigger, which is a stimulus to external events through feeds. We have rules that will tie a feed, a trigger with an action, and vice versa. And finally, the activation that we saw previously, where I executed a function and got the result later from an activation. And to show how that works, feeds and events, I want to go to a more complex scenario here. What I will do is post a message to Apache ActiveMQ, and then there will be a feed that will feed my my environment and trigger the function, because once that it feeds, I will create a rule that will trigger that function, and then that function will invoke the splitter, the sorter, the uppercase, and it will also invoke another function here that's called sender. The sender will place the message back to ActiveMQ. So you can see that how it can work asynchronously. So first things first, let's get the existing package, because I have already deployed the package here. So WSK package list. I have a package here called message demo. Let's get this package get, so we can take a look on what's inside this package. And something that's also interesting, I can have parameters in a package, so every function inside the same package will have that parameter defined. So this package here has the broker host, the broker port, which is the Apache ActiveMQ. In this case, I'm using Artemis. And the actions, message sender, implemented in this case using Node.js, sorter that uses Go, uppercase that uses Java, splitter that uses Python. Okay, so let's do the following. First, let's create a trigger. The trigger will do the following. It will look for, it will use this connection options here, the host and the port, and it will listen for the Q99. That's why the trigger, it's called trigger Q99. Okay? So now that we have that trigger, we can create a sequence of functions that will invoke the sorter, the splitter, uppercase sorter, and sender, the message sender. Okay, and now finally, I can have a rule that will say if the trigger Q99 is triggered, then call this function split, sort, up, and UCase. Okay, now I have everything tied together, and I can invoke my test application with demo receive that will listen for a queue called reply Devoxx. Okay, so I'm listening to everything that will be placed on this queue. Okay, now in the other hand, I can, let me increase the font size to help you all. I can use a node application that will post on the Q99 some strings as well. So let's use the same string. Rafael Benevides, Poland, Java, Devoxx, Krakow, what else? It's fine. And another parameter here is reply. So reply to, I want to reply to that topic there, to that queue. Devoxx, yes, Devoxx. Okay, I will send the message, and let's wait. We can see that by the activation here, it called the functions, and now we have the result here posted on this queue. Benevides, Devoxx, Java, Krakow, Poland, and Rafael. So this is a really nice and advanced example. To complete, I'd like to say that there is a specification being defined for cloud events. It's an effort managed by CNCF. You can see that in the Cloud Events IO website. And to know more about, you can just place your email and you will receive news about this working group. The example that I used, you can run on your machine. If you go to this link here, bit.ly/, FaaS tutorial, function as a service -tutorial, you will see a GitHub repo that allows you to set up Minishift, which I'm using, set up OpenWhisk, and then deploy all your actions and web actions and sequence and even the advanced part for this demo. So thank you so much for your presence. I guess that we should have moments for 1 or 2, maybe 3 questions, right, Martin?
Yeah, fine. Anybody question?
It means that everyone understands everything, or that you are shy. I don't think you are shy.
Okay.
Okay, so thank you so much.